All right, in this section, we're going to be looking at a concept called elasticity of demand. And this will be section 3.4 in our book. And again, the title here is going to be Elasticity of Demand. And to get started, I'll go ahead and write down a formula for this concept, and then we'll talk a little bit about that formula first. And so I'm going to call this E, capital E of P. And before I write anything else down, I'll say the E there stands for elasticity. And the P, that's one of our common variables this semester, that's going to stand for the price of whatever it is that we're selling. And now this E of P, this is going to equal negative P times F prime of P, all divided by F of P. And here, I'm going to make a special note here, so where F of P is equal to X, where X is the usual demand that we've been discussing so far this semester. I'll say much more about that relationship there once we start doing examples, but we've been used to seeing f of x in math and even a little bit this semester, but we're going to have f of p here. That's not a super big deal when it comes to the derivative or anything like that, but we'll discuss that more when we go into an example in just a moment. Other thing I want to mention here really quickly is this negative here. It's kind of an oddball. So that negative is just, it's just for convenience. It's just, just typically denoted, let's say, typically negative. The only reason that negative is there is you'll usually get a negative for this value, p times f prime of p divided by f of p. That value will usually be negative. As you increase price, demand tends to go down. Not always, that's not always the case, but it tends to go down in most cases. The demand will go down when the price goes up. And so you typically get a negative value there. And once we start talking about what this actually means, it's just a little bit easier for economists and other people who talk about elasticity to say, oh, the elasticity ended up being 3, or it ended up being 5, or it ended up being 0.5, instead of having to say -3 or -5 or -0.5. So that negative there, it's just a very convenient thing to have in our formula. It just kind of makes the answers look a little bit better because they'll typically be positive. So that negative is really just there to make that E of P positive. So to make E of P positive or greater than 0, however you'd like to say that. And I'll put a few more thoughts down here before we start doing examples. Specifically, we're going to have some words, some buzzwords here that I want you to know and that your homework will ask you about, the quiz will ask you about, the next test will ask you about. In particular, if this elasticity, we haven't done an example yet, but if we figured out the elasticity of a certain price for a certain product, if this ends up being greater than 1, then we say, then the function is elastic. And I'll talk much more about this after we do our first example, but I'll speak a little bit to that right now. So if E of P is greater than 1, the function is considered to be elastic. And what this means is if you change the price by a certain amount, if E of P is greater than 1, if your function is elastic, you can expect the demand to change by more than that same amount, relatively speaking. On the other hand, if you had E of P is less than 1, then the function is called inelastic. And in that case, if you change the price a little bit, the demand itself is going to change by an even smaller amount relative to how that price was changed. And one more case here, you can probably guess what it is. If E of P is equal to 1, then the function, we're going to call that is unitary. And what that means is if you were to change the price a little bit, you can expect the demand to change by roughly the same little bit, whatever that was. So definitely when you write down your notes here, you definitely want to have the formula for elasticity there with that negative P times F prime of P divided by F of P. You definitely want that in your notes before you do the homework and before you take the quiz and the next test. And then let's see here, we want to know what those words elastic, inelastic, and unitary means. Those will kind of be add-on questions to the homework problems for this section. You'll figure out E of something, maybe E of 10, and then it'll ask you after you're done with that, is that elastic? Did it end up being inelastic, or was it unitary? And so that's kind of the general stuff out of the way there. We'll go ahead and get started with a particular example. And let's see here. So for our first example, I'll start with something that I would consider to be a little bit more maybe simple as far as the function is concerned. So let's say for our first example, let's do given, and on all these problems, you'll be given a price demand equation. So given P is equal to negative 0.02 times X plus 400. So that's our price demand equation. Now, just for reference, I'm going to go ahead and write my formula for elasticity off to the side here, just since it's up above in our notes. I want it here so I can keep it in mind. So elasticity is negative P times F prime of P, all divided by F of P. And again, one very important thing there, our function is in terms of P. And so when we take the derivative for the numerator, when we rewrite it for the denominator, we need to have a function in terms of P. Right now, our function is in terms of X. We have a function for P in terms of X. We need to flip that around and solve for X first so we can have X equal something with P in it. And so the first thing I'm going to do here, I'll go ahead and write this down. First, solve for X. And so first thing I'm going to do here is solve for X. And you can do that however you would like. And I'm going to go ahead and add 0.02x to both sides just to make that positive. While I'm at it, I'll go ahead and subtract P from both sides as well. And then the next step, I think a good one is to divide both sides by 0.02. Now, technically, we have X solved for there. If you want to find the elasticity now, you can. Eventually here, I'm going to want you to find the elasticity. Let's throw that in there. Let's find E of P. So you could do that now if you want to. I'm not a big fan of how that X is written, so I am going to do some rewriting here just to make this formula, or just to make this equation look a little bit more nice. And so let's see here. I'm going to go ahead and split up this fraction. So I'll say 400 divided by 0.02 and then minus P divided by 0.02. And since I've done that, I might as well go a step further and say, okay, well, maybe I need a calculator for this. 400 divided by 0.02, from my calculator, that is 20,000 minus P divided by 0.02, or you could think of it as 1P divided by 0.02. 1 divided by 0.02 is 50, so that'll give me a 50p there. That looks a little bit more nice, in my opinion. You can agree, disagree, it doesn't really matter there. So first I wanted to solve for x, because that is my actual f of p. So f of p, my function in terms of p, really just all we need to do is solve for x in order to come up with that function in terms of p. And I need that function in terms of p because it shows up twice in the formula for elasticity. It shows up in the denominator as is. the derivative of that function also shows up in the numerator. So a good next step, in my opinion, is to go ahead and find the derivative now. So I'm going to next to find f prime of p. Or if you wanted to call it x prime, that's fine as well. Same thing, x or f of p are the same thing in these problems. If we stick to the formula, it has an f prime of p there. Not too bad. The derivative of 20,000 is 0. I won't write the 0. The derivative of negative 50p with respect to p is going to be negative 50. So p is a variable there, so we'll take the derivative with respect to p, and I get a negative 50 for that. Now let's go ahead and actually do, I'll call this part A for this problem. We haven't really started this problem yet. Let's say find E of p. And so I'll go ahead and rewrite that formula again. Negative p divided by f prime of p, or sorry, negative p times f prime of p divided by f of p. And let's see here, so negative p, I'll leave that alone for now. F prime of p we just figured out. That was negative 50. All divided by f of p, we had figured that out on the previous step. That was 20,000 minus 50p. And now here, if the question only asks for E of p, technically this is fine. This is a perfectly good answer. We found E of p. Part B, I might ask for something else. I might want us to plug in something here. So I'm actually going to go ahead and simplify this again, just in case I need to plug in something later. I'll go ahead and simplify this first. So negative p times negative 50 is 50p. In that denominator, just because I already noticed that we have that 50 in the numerator, I'm going to go ahead and factor out a 50 in the denominator. I think that'll be useful later on, maybe even on the next step. So I'll go ahead and factor out a 50 in that denominator. That's going to leave me, when I take 50 out of 20,000, that should be 400. And when I take 50 out of negative 50p, that should be a negative p. And now, sure enough, immediately I can cancel those 50s now. So a little bit more nice again. That leaves me in the numerator with just a p, and in the denominator, 400 minus p. So that's a pretty nice version of E of p there for part A. So I found the elasticity for this particular price demand function. Now that we've found that, let's go ahead and do something else with it. Let's say for part B, let's go ahead and let's find E of, let's do E of 100. Now, a question like this, you've already found elasticity. If somebody asks you to find E of 100, they want to know the elasticity of the particular price, $100 or whatever the currency is. In this case, let's see here, if we plug in 100 for P, we'll get 100 divided by 400 minus 100, minus P there. I'm plugging in 100 for P. That gives me 100 divided by 300, which is 1/3. And as always, just round to whatever you're asked to round to. Let's say it was 2 decimals here, so we get a 0.33 for E of 100. And I'll go ahead and go a step further and say, okay, well, the elasticity E of 100 is equal to 0.33. That is less than 1. So this function is going to be considered inelastic when the price is 100 in this case, and maybe it was dollars, maybe it was something else, but either way, it's going to be considered inelastic. And since we have that up for part B anyway, I want to go ahead and say a little bit more just to kind of show you what this means. As far as the homework or the quiz or the test is concerned, this is what I want you to know. Be able to find the elasticity, be able to plug in something, Keep those words in mind. Less than 1 is inelastic, greater than 1 would have been elastic, equal to 1 is unitary. But since we have this good example up here, I'll go a step further and write out a little bit more here in terms of what this actually means. You don't need to include this next part in your notes, but I think it's interesting in terms of what this actually means. So, finding that E of 100 is equal to 0.33, what this means is if the price is $100 or whatever it might be, so if the price is 100 and we increase the price by something small, let's say 1%, and we can expect the demand to decrease 0.33%. So elasticity, it just kind of shows you how the price and the demand are related together when you make a small change in price. So if the price is $100 and we increase price by 1%, then we can expect the demand to decrease by 0.33%. Now, one thing that's a little confusing is we got a positive 0.33. Why is the demand decreasing? Again, we're typically going to get positive answers for these problems, for these elasticity problems, but that's only because of that negative in the formula, that negative P times F prime of P divided by F of P. So, the demand is actually, in this case, and typically decreasing when the price is increasing. Even though we get a positive elasticity, it's just easier to say 0.33 than it is to say negative 0.33. But the demand is going to decrease here. And I'll go ahead and do another one very similar to this. Let's say, let's do part C here. And I'll go ahead and rewrite my E of P in just a second. But let's find E of, let's do 300. And my E of P, I'll put it off to the side here. So E of P, sorry, I'll scroll back up here. P divided by 400 minus P. So P divided by 400 minus P. So E of 300 is going to be 300 divided by 400 minus 300, which is 300 divided by 100. Which is 3 there. And so let's see here. Go ahead and box that answer. I also noticed 3 is greater than 1. So if somebody asks me, hey, is this inelastic? Is it elastic? Is it unitary? It's greater than 1 here. So that is going to be elastic. And then I'll make a similar statement as I did above for E of 100. So, and this part you don't need to do, you don't need to write down, but I want to just because it's our first time talking about elasticity. So if the price is, what was it in this case, 300, and we increase price by 1%, then we can expect the demand to decrease. In this case, we got 3 for E of 300, so we can expect it to decrease by 3%. And I'll do one last one. I imagine you can probably guess how the last one's going to turn out, but let's do it nonetheless here. Let's say this is part D. Let's find E of 200. Oops. E of 200. I still have my E of P up there. It's P, so 200 divided by 400 minus P, so minus 200. That'll give me 200 over 400 minus 200 is 200. And 200 divided by 200 is 1. And anytime you get 1 for elasticity, that stands for unitary. And that word unitary, you might think of unit or uni or something like that. And, it kind of represents that one-to-one nature of this price and demand, how they change in relation to one another. And I'll go ahead and write that out. You don't have to, but if the price is $200 or whatever it might be, and we increase price by 1%, then we can expect the demand to decrease. We got 1 there, so by 1%. So unitary, everything's kind of staying equal to one another. One's increasing, one's decreasing, of course, but in the same way, relatively speaking, by about the same amount there, as opposed to elastic, you can expect a greater change, or inelastic, you can expect a smaller change in relation to how the price changed in terms of the demand. Yeah, let's see here. So that'll do it for that first example. We'll go ahead and do one more of these. And so I want to do something with what I would consider to be maybe a more complicated function. So maybe something, let's say, similar to this. So let's say, I'll give you a price demand equation. Price demand has to be given to you here. Their relationship definitely has to be given to you on these problems. Like the previous one, I gave us P equals, so we are going to have to solve for X first. If you already had X equals, that's fine, that's great, that's a good thing. You could just immediately start, take the derivative, plug it into the formula. But like in this case here, if you're not given X equals, if you're just given P equals, you do have to find X first. And then you want to plug it into your elasticity and answer any questions that were asked. In this case, let's just say, given this price demand equation, let's just do something in particular. Let's say I want you to find E of 35. And then we could do the normal. We can figure out if it's inelastic or elastic or unitary or whatever it might be. So given P equals 141 minus X squared, let's find E of 35 first, and then we can talk about that a little bit further. So in this case, again, we're not given X equals, so we do need to get that first. Please solve for X however you'd like. I'm going to add X squared to both sides and subtract P from both sides. And now that I have X squared over there, no negative in front of it anymore, I am going to take the square root of both sides. I'm going to ignore the negative square root just because, it really wouldn't make any sense to talk about a negative demand. We want our demand to be positive, or worst case, 0. We don't want it to be negative, so I'm going to ignore the minus and the plus or minus from the square root. Not surprisingly, I'm not a big fan of how that's written. I will go ahead and remind us that, okay, well, if you have X now, that really just stands for f of P. And I'm going to change that as well in this same step. I don't like those square roots. I'll change that to a 1/2 power. I'm going to change that to a 1/2 power because I personally think that makes it easier to find the derivative. It looks like just a basic power rule now. We can bring down the 1/2, keep the inside the same, subtract 1 from the power. 1/2 minus 1 is negative 1/2. And then don't forget to do chain rule on a problem like this. The derivative of 141 is 0. I won't write it. The derivative of negative P is negative 1. I will go ahead and write that. And now I feel comfortable finding E of P. Eventually I need to find E of 35, but I do feel comfortable now finding E of P. So I'll go ahead and start that process. I'll rewrite my formula. Negative P times F prime of P divided by F of P. And let's see here, plugging in there, we have a negative P. That's always there. That's going to show up in every one of these. It might cancel at some point. It's possible, but it's always going to show up in the formula itself. F prime of P, we just found that. That was a 1/2, a 141 minus P to the negative 1/2, and a -1. We are going to divide that by F of P. That's on the previous line. That's 141 minus P to the positive 1/2. And, eventually we just need to find E of 35. If you want to plug in 35 right now for every P you see, that's fine. You can do that. You can plug it into your calculator, no big deal. If you'd rather not plug in right now, if it looks too complicated to plug in, not surprisingly, I think that, I'm going to go ahead and do some simplification first. You definitely do not have to do this, but I think it's worth doing some simplification here. So let's see here. It looks like I have on top, I have a negative P times a -1 at the end there. I'll make that a positive P. I also have a 1/2 there. I'll go ahead and keep the 1 in the numerator. I'll move the 2 into the denominator. In that denominator, I already have a 14, actually that should be a 141. So I have a 141 minus P to the positive 1/2 power. I also in the numerator have a 141 minus P to the negative 1/2. I'll move that down and make that exponent positive. So moving it down there, we'll change it from a negative 1/2 to a positive 1/2. And I'm feeling a little bit better about how this looks. So the numerator certainly is much more simple. The denominator, I think we can do better. So we have 141 minus P to the 1/2 times 141 minus P to the 1/2. Let's look at something a little bit more simple. Let's say it was y to the 1/2 times y to the 1/2. To multiply something with the same base, you add the exponents. Well, 1/2 plus 1/2 is just 1. And so I'll do the same thing here. My base is 141 minus P. And then 1/2 plus 1/2 just gives me a 1 there. So a little bit more simple there to look at that E of P rather than how it was when it was unsimplified. On this particular problem, I wanted us to find E of 30. Actually, I forgot what it was. Let me go check really quickly. E of 35. So I wanted us to find E of 35. So when I do that, I'm going to plug in 35 for all the P's there. So there's a P in the numerator, plug it in there. A 2 times 141 minus P, so minus 35 there. And let's see here, 35 is okay. Oops. 35 is okay in that numerator. 2 is just kind of hanging out there. I don't have any problem with it right now. 141 minus 35 looks to be 106. That's being multiplied by that 2. And that'll give me a 35 over 212. That's as far as I'm going to be able to go there without a calculator. I'll go ahead and plug it into a calculator now. When I do that, I got a 0.165. Again, just round it to whatever you're asked to round it to. And then typically, maybe not always, but typically on these problems, you'll be asked, okay, find E of something. In this case, E of 35 is equal to 0.165. And then you'll be asked, is it elastic? Is it inelastic? Is it unitary? In this case, this elasticity was less than 1. So that is going to be inelastic. And since it's our last example anyway, I'll go ahead and write out the explanation there again. I'm not super concerned about that right now in our math class, but in terms of what does elasticity actually mean. So in this case, if price is $35 or whatever the currency is, and we increase price by 1%. 1% is just a nice number to look at. If we increase the price by 1%, then we can expect the demand to decrease by 0.165%.